Hello, good morning. Today we are discussing a very important topic in plus 2 physics, that is capacitance of spherical conductor. Spherical conductor. We know that we know the spherical shape. We consider a spherical conductor here, and it have a radius r. It have a radius r. We want to find the capacitance of this conductor. We want to find capacitance of this conductor. So we take the we know already studied the equation of capacitance, basic equation of capacitance, that is C is equal to Q by V. C is the capacitance and Q is the charge. Q is the charge stored, charge present in this conductor, and V is the potential. V is the potential. We also know the equation of potential. It is studied earlier. V is equal to equation of potential. V is equal to 1 by 4 pi epsilon Q by R. In here, we not use an epsilon 0 because why? In so many equations we using epsilon 0, but in this case we not use epsilon 0 because it is not an air. It is not an air or vacuum. It is a conductor. It is a conducting material. So the permittivity is taken here, and permittivity of this material, that's represented by the letter epsilon. So we not take an epsilon 0 here, just like epsilon. Okay. Then we apply potential. Equation of potential in this equation is applying here. V is replaced by the 1 by 4 pi epsilon 0 Q by R. Then we get an equation. Just look at it. C is equal to Q by, then replace V by this equation, 1 by 4 pi epsilon Q by R. Anything else cancel here? Yeah, Q is cancelled here. Then we studied a basic maths. This is the third layer, so it is come to here. So C is equal to 4 pi epsilon R. This is the equation of capacitance in spherical conductor. We get an equation. Okay. Then replace the epsilon by, we also study the epsilon. Yeah, this is the permittivity of this material. Okay. Epsilon here that is equal to epsilon 0 into epsilon R. What is epsilon 0? Epsilon 0 is permittivity of air. Epsilon R is relative permittivity of this medium. Okay. Then replace this equation like this. C is equal to 4 pi epsilon 0 epsilon R into R. What is R? What is R? We also say that R is the radius of the conductor. Now we make another equation for radius of conductor. If we know the capacitance of this conductor, we can find the radius. Okay, just make an equation for the radius of this conductor. If we know capacitance, what is that equation? R is here, and this is come to this side. So the equation is like this: C by 4 pi epsilon 0 epsilon R. Okay, that is the equation of radius. Okay, this is a very important topic. I think you can clear this. Okay, now we are discussing another topic, that is parallel plate capacitor. Already we studied about the capacitance of a spherical conductor. Now we are discussing about parallel plate capacitor. What is parallel plate capacitor? We know that capacitor having two plates. One plate is storing positive charge, another plate is having negative charge. So in parallel plate capacitor consists two similar plates separated by a distance. Okay, then it have a small distance between the plate is representing by the letter D. Distance between the plates is representing by the letter D, and if we give a positive charge to first plate Q, the amount of charge, positive charge is Q, then equal negative charge is induced in the second plate. Equal negative charge is induced in the second plate. This is positive plate, this is negative plate. Okay, you can clear this. And another thing is, the same plate is here, so the area of the plate is A. The both are same. Okay, 3 points. First, distance between the plate is D, and the charge stored in the plate is Q, and the area of the plate is A. Okay, we know the some basic equations. That's previous we are studying. First of all, surface charge density, that is studied in previous class. Sigma, it is represented by the letter sigma, that is Q by A. That is the equation of surface charge density. Okay, then electric field intensity between the plate. That is, we are studying in Gauss's law. Application of Gauss's law, we are studying the electric field intensity between two sheets. Yeah, what is the equation of electric field intensity between the sheet? That is sigma by epsilon 0. Why we considering the epsilon 0? We also say that there is no dielectric in between the plate is presenting only air. So we can taking epsilon 0 here. Okay, then we also study the an equation of potential V is equal to E into D. That's the basic equation of potential. We know that the equation of potential is 1 by 4 pi epsilon 0 Q by R. Then equation of electric field intensity is 1 by 4 pi epsilon 0 Q by R square. Then R is the distance in that two equations. In this equation, the distance is representing by the letter D. That is the difference. Okay, just if we considering that two equations, we get in equation like this. We are also discussing about this equation. I think you know that these three equations. What is sigma? That is the surface charge density of this sheet. That is equation of sigma is equal to Q by A, and electric field intensity is equal to sigma by epsilon 0. Then V is equal to ED. These are the three equations here. We just replace this equation by like this. V is equal to E is replacing by this. Equation. Then what we get? Just sigma by E sigma by epsilon 0. Then E is replacing and D. Also write like this. Then we want to find the capacitance of parallel plate capacitor. What is the equation of capacitance? C is equal to Q by V. Yeah, C is equal to Q by V. So we get an equation for Q from this. When you get an equation for Q from this equation, Q is equal to A is come to here and sigma into A. Is it correct? Yeah. So we just apply here. Q is replacing by sigma by A, and V is replacing by this equation. V is replacing by this equation. So sigma D by epsilon 0. Okay, we can see that sigma are cancelled, and epsilon 0 is in very lower side, so it is come to here, and C is equal to epsilon 0 A by D. Epsilon 0 A by D. This is the equation of capacitance of parallel plate. It is the equation of capacitance in parallel plate. Capacitance of parallel plate. If this equation is only using if there is no dielectric, there is no medium between the plate, only air is present here, then we can use C is equal to epsilon 0 A by D. Okay, from this equation we can understand something. What are the factors depending the parallel plate? What are the factors depending the capacitance of parallel plate capacitor? What are the factors depending the capacitance of parallel plate capacitor? Just say here. First of all, A. What is the A? Area of the plate. Yeah, that is the first factor depending the capacitance. About first factor is area of the plate. Area of the plate. Area of the plate. That is the first factor. Then D. What is D? D is the distance between plates. D is the distance between plates. That's also depend the capacitance. Distance between plates. And third one is epsilon 0. Epsilon 0 means permittivity of the air. Where is air is presenting? The air is present between two plates. If we replace another material like wood or another dielectric material here, we get another capacitance value. That is epsilon 0 is replacing by epsilon if you are using a dielectric. So dielectric is also depending factor of capacitance in parallel plate. Then third factor that depending the capacitance of parallel plate capacitor is dielectric used between two plates. These three factors are depending the parallel plate capacitor's capacitance. Okay, I think you are clear these two topics. Today we are discussing two topics. First of all, capacitance of spherical conductor and capacitance of parallel plate capacitor. Okay, thank you.